Hai, assalamualaikum, welcome back to my YouTube channel. Okay, so for this video I'm gonna present to you about my assignment, which is assignment from MEC451, which is thermodynamics in UITM. I have to solve the practice problem 3.3 and the question number is number 2. So before that, I want to introduce myself first. Okay, my name is Nur Amalizati binti Azli and my metric number is 2020601772 and I am from EMD2M2A1 group. Okay, so without wasting our time, I'm sorry for my speaking. So without wasting our time, we proceed to our question. Let's wait. Before we proceed to our question, don't forget to like, subscribe, and turn on notification. Ting ting. Let's proceed to our question. Let's go. Okay, so this is my assignment to present to you about my solving practice problem 3.3, which is the number question is number 2. Okay, so first we have to read the question first, and let's read the question. Okay, so a pump increases the water pressure from 100 kilopascal at the inlet to 900 kilopascal at the outlet, where water enters this pump at 15 degrees Celsius through a 1 centimeter diameter opening and exits through a 1.5 centimeter opening. Determine the velocity of the water at the inlet and outlet when the mass flow rate through the pump is 0.5 kg per second. Will these velocities change significantly if the inlet in temperature is raised to 40 degrees Celsius? At first, I'm sorry for my bad language speaking, maybe. Okay, without wasting our time, let me continue. So we had read the question for the first time, and for your information, when we want to solving the problems about the question like this, we have to read twice. We have to read the question twice. So we proceed to our second reading, which is when we do the second readings. While we are reading, we have to come out with the information given in the question. I'm sorry. We have to come out the information given from the question. Okay, so let's proceed. Okay, now a pump increases the water pressure from 100 kilopascal at the inlet. So the keyword here is the inlet. So we come out inlet here, and this is we state as P1 because the inlet I state as P1. So here P1 100 kilopascal, and continue to 900 kilopascal at the outlet. So the outlet is here, and we assume as 900 kilopascal is as P2. So that's the first information given from the first I mean, what is this? From the first never mind. So let's continue. Water enters here is meant inlet. Enter here mean inlet. So water enters this pump at 15 degrees Celsius through a 15 degrees Celsius through a 1 centimeter diameter opening. So here we take this 50 degrees Celsius, which is the temperature one, and I state this as T1, and also 1 centimeter diameter opening, which is D1 1 centimeter, and also we have to convert it to 0.01 meter, which is we have to use meter in our calculation later. So continue. and exits. So exit is outlet. Exit through a 1.5 centimeter opening. So here 1.5 centimeter opening is, as we take as D2, which is 1.5 centimeter, and then we convert it to 0.01 meter because we want to use meter when we do calculation later. So proceed. The question is, determine the velocity of the water at the inlet and outlet when let me change the color first. When the mass flow rate through the pump is 0.5 kilogram per second. So this is the another information, which is mass flow rate through the pump is 0.5 kilogram per second, which is here. I put this here. Mass flow rate, which is the M with the dot above that. Let me clear you. Can you see here, which is M have the dot above that. So let me continue, which is the last statement. Will the velocities change significantly if the inlet temperature is raised to 40 degrees Celsius? So I assume here as a state 2, which is the inlet, and T is 40 degrees Celsius. And the question here, it want to find the velocities, so I put as V1. And also the state 1, it want V1, which is V inlet, velocity inlet, and V2, which is the velocity outlet. So without wasting our time, let's proceed to our calculation. Here I'm starting with statement 1, which is the information given here. You can look here. This is conclude too. So for the inlet, the question wants us to find velocity. So I use the formula here is mass flow rate equal to density of water multiplied by area and multiplied by volume. I mean velocity, I'm sorry. And the information given is D1, which is 0.01 meter. I took the meter, I used meter. So, and the radius is 5 times 10 power of -3 meter. Because we need this radius, we want to find this area. And the area formula of the circle is A equal to pi multiplied by r square. So we proceed to the calculation. We put the number into the formula, and we get the area is 7.854 multiplied by 10 power of -5 meter squared. So, and then we proceed the value of the area into the formula of V equal to mass flow rate divided by density multiplied by area. So here we put the value, and then we get the velocity inlet, which is 6.37 meter per second, and we get the answer of V1. Also, the outlet, the question wants us to find the velocity outlet, which is the same. We can use the same method as we find the velocity inlet. So we just proceed it. We have to the information given is the 2, which is 0.015 meter, and the radius is 7.5 multiplied by 10 power of negative 3 meter. So the area is like the same method above here. We can find the velocity outlet. So just proceed it, and we get the answer is 2.83 meter per second, which is the velocity outlet. So for the last question, for the last statement, I mean statement 2, will this velocity change significantly if the inlet temperature is raised to 40 degrees Celsius? So the statement 2, inlet, and the temperature is 40 degrees Celsius, and I'm saying we're gonna use the same formula as we find the velocity in state 1, just a bit different. Before that, we put the information given first, which is the temperature is 40 degrees Celsius, which is here, and the area of inlet is like the same as the inlet in statement 1, and the mass flow rate also constant, which is the same as the statement 1. And we can look here from the formula. We can use a bit different, which is we can convert this density equal to 1 over specific volume, which is we can find the specific volume in table A4 like I stated here. So as the temperature is 40 degrees Celsius, and which is here, we can look and we can get the saturated liquid is 0.001008 meter cubed over kilogram. I'm sorry if I'm stuck a bit. And then we proceed. From the formula we get, we use the same formula as this one, which is M equal to density multiplied by area and multiplied by volume. So we proceed to the formula, which is V inlet equal to mass flow rate divided by density multiplied by area 1. Because we want to find the inlet, we use the area 1. So we can convert the density here as the formula I state here, which is 1 over specific volume, because we have got the specific volume in the table beside here. So we get this value, and we just proceed the formula from this, and we got to this, which is mass flow rate multiplied by the specific volume divided by area 1. So we just put in the value in the formula, and then we got the value, we got the answer for for the velocity inlet when the temperature raised to 40 degrees Celsius. And the final answer, as you can look here, it asks will this velocity change significantly if the inlet temperature is raised to 40 degrees Celsius? And the answer is, as you can look here, in here is 6.42 meter per second, while V1 here is 6.37 meter per second, and the answer is yes. The velocity change. So that's all for my explanation for my presentation of solving the practice problem 3.3. So that's all for my presentation video for today, which is the solving problem of practice problem 3.3, and the number question is 2. I hope you like it and you can understand what I might present to you. And yeah, thank you for watching my video, and don't forget to like, subscribe, and turn on notification. Ting ting. So until we meet in the next video. Bye. Assalamualaikum.